Hello, everyone. My name is Cesar. I am a master's student in the agronomy department here at Kansas State University. And today I'll be talking a little bit more about the importance of soil aggregation and structure to avoid erosion. So what is soil aggregation? Soil aggregation is the arrangement of the primary particles of soil, such as clay, sand, and silt, around soil organic matter. And you can see in the picture on your left a simple representation of a soil aggregate, and it may seem simple, but if you take a closer look in the picture in your right, we can see that in fact, this aggregate is a really complex system where we can find the plant roots, plant and fungal debris, the soil particles by itself, such as clay, silt, and sand, as well as other biological, chemical, and physical compounds. And how do we classify soil aggregates? So we have three major classifications for soil aggregates, which are large aggregates, which are the aggregates larger than 2,000 micrometers, macro aggregates, which are the aggregates ranging between 250 and 2,000 micrometers, and microaggregates, which are the aggregates ranging between 53 and 250 micrometers. And why and what is the importance of this soil aggregation? So a soil well aggregated will protect organic matter. That's important for nutrient cycling and availability for plant uptake, as well as biological diversity and activity in the soil. It will also play an important role on soil physical components, such as soil porosity, which will increase the soil water storage capacity, as well as the drainage of this water in the soil and the availability of this water for plant uptake, and as well linked with these physical compounds, it will decrease soil compaction. And what influences soil aggregation? So we have the environment, the climate by itself have a huge influence in soil aggregation. We have years where we have a normal regime of precipitation, and we have years which with drought. So it will have an impact of this soil characteristics. The soil management also plays a really important role in characterizing this soil aggregation, and practice like tillage will break down this soil aggregation, and no tillage, for example, will protect this soil aggregation. And we also have plant influences, like different plants have different root systems and root depths that will for sure influence the state of soil aggregation in different situations. And we have also soil properties, like different soils, different types of soils have influence on the aggregation by itself. And bringing the subject to a more agricultural world, we have, for example, the effect of some agricultural management practice on soil aggregation. So soil agricultural tillage, for example, has a negative effect on soil aggregation, as I mentioned before, because it mechanically breaks soil aggregates and leaves the soil surface exposed for weather factors such as rain. So it will leave the soil exposed to water erosion problems. So in the water erosion process, we have the detachment, which is the physical break of this soil aggregation by the water drop by itself. And we have the detachment, and then after the detachment, this soil particle or this soil aggregate will be carried over by the water and will be deposited in somewhere else where most of the times it doesn't belong. And then we have, as a result, this soil loss, most of the times the more fertile layer of our soils, and it can lead to soil contamination of water bodies and underground water, for example. And what are the alternatives to avoid erosion in a soil aggregation perspective? So we have the no-tillage system where we prioritize the minimized soil disturbance. We have soil permanent cover, like which will provide protection against erosion to keeping the soil with a layer of plant material, and we will be protecting the soil from that physical break from the water drop in the soil, as I mentioned before. And having living roots as much as possible in our soil, diversification of the plants and different root systems, some of them like really deep, some of them a little bit shallower. So we have this diversification of root systems, which will increase soil porosity and some physical, biological, and chemical characteristics of the soil in question. And also, the most important factor is like to have an increase and protect soil organic matter. And here, it's a video of an experiment, a really simple experiment that I'll be showing you guys with 3 different land use soils. One of them is native prairie, a soil that was never under tillage, a soil under no tillage, but that was previously tilled in the past, and a soil under a full or under a conventional tillage system. And you can see in this video demonstration how easily this soil disaggregate in water. The soil in question is the soil under tillage, conventional tillage system. How easy the soil disaggregate when it contacts with water.
So okay, here we're going to conduct a really simple experiment just to try to evaluate the aggregate stability under 3 different field conditions. We have here native prairie, we have here a field or a soil from a field under no tillage, and here soil from a field under conventional tillage. So we can start with native prairie. You can observe that just a little bit of the soil disaggregated, so it has a really good aggregation and like a really good water stable aggregation in this situation. Moving forward to the no tillage field, we can see that we lose more soil if you compare with the native prairie situation, but it's not so much. And then moving forward to the conventional tillage field, we can observe that the soil aggregation is worse. And as I mentioned before, by the operation of soil tillage, we mechanically break these soil aggregates, and then we have a way more susceptible conditions for water and wind erosion. I hope this video is helpful for you guys, and thank you so much.
Okay, so in this short presentation, we reviewed the principles that affect the importance and what we can do to protect, enhance our soil aggregation. And if for any question or additional resources, feel free to contact me in my email below. And I hope that you could learn something today. And thank you so much.